Hi folks, welcome to 8.4 Polar Graphs Part 2. And in this video, we're going to talk about Rose curves, all right? And so the way we're going to look at Rose curves, we're going to look at two different cases. So each case looks at a sine and a cosine, but we're going to look at an equation that looks slightly different from the circles we just looked at. And so in particular, we might notice that sure, we have this A in the front, which is a constant. We've got this A in the front, right? All these constants. But now we have another letter. We have this N, all right? N is also a constant. But we're going to first take a look at a case when N is even, okay? And then we're going to take a look at when N is odd. All right, so looking at sort of similar equations, but really when A is even or N is even or odd. Okay, so let's go back to our Desmos screen. Let's take a look at that. All right, so here we've got our Desmos, and we're looking at when N is even. Okay, so right now, we are focusing on the A sine of n theta. So let's see what happens when n is 2. Oh, I see a graph here that's got 4 petals, okay? Each of these is what we call a petal, and we see 4 of them. Well, I wonder what's going to happen if n equals 4, another even number. Oh, we've got 1, 2, 3, 4, 5, 6, 7, 8 petals. Okay, well, if we have 4 petals when n is 2 and 8 petals when n is 4, what do we think we're going to have when we have n equals 6? All right, I'll give you a moment to count those. But we should end up with 12, okay? Now, that's just the n. It looks like n talks about the number of petals. Let's go back to a more manageable petal size, 2 or 4 petals. All right. What happens when I make A bigger or smaller? All right. So let's make A bigger, bigger, bigger. And it looks like A actually measures the petal length. Okay. So how long the petal is, that is determined by our A. All right. Let's turn off the sine theta one for a moment. And we're going to go back to this n. I want step 2, but I want to start at 1. Okay, so now we're going to look at the odd ones, and I'm going to take a look at cosine. All right. All right. I see 4 petals when n is 2. I see 8 petals when n is 4. And I bet I'm going to see 12 petals when n is 6. So where do we have that axis of symmetry? I think it's actually hard to tell in the even case, all right? But for right now, let's write down what we've seen, and we're going to write that down in our notes, okay? So let's go back to our notes. All right, n is even. When n is even, then we see 2n visible petals. All right, we see 2n visible petals, meaning if n is 2, I see 4 petals. If n is 4, I see 8 petals, okay? Now for the sine one, I believe we had something kind of like this. We've got sort of 1 petal, another petal, another petal, another petal. And then our A is actually this distance right here is our A. Okay, so the larger A is, the longer the petal is. Now, if we go ahead and draw the same thing over here, but except for our cosine one, we should get 1, 2, 3, 4. And this distance is our A. Okay? So if we think about all of these, we've got 4 petals when n is 2. And again, we could draw more for the larger the n. Okay? But let's take a look at what happens when n is odd. All right, so we're going to go back to Desmos. We're going to take a look at when n is odd and see what happens. But I bet A is still going to take a look at that petal length. Okay, so let's look. All right. Let's change that to 1. Oops. All right. And let's see what happens. Let's start with the sine one this time. You've got sine. What happens if we change n to, whoops, let's go to 2. Whoop, let's go to 1. All right. So when n is 5, I actually see 5 petals. But what about if n is 3? I see 3 petals. What about if n is 7? I see 7 petals. Okay, so the number of petals that we see when n is odd is actually exactly the number of petals. Okay. Same thing here. If it's cosine, I still see 7 petals when n is 7. I see 5 petals when n is 5. I see 3 petals when n is 3. Okay. So if we were to go ahead and draw these on our notes, let's see what else we might want to write down. All right. So when n is odd and we have cosine, let's say 3, we end up with something like this. Okay. And this distance here, this is our A, our petal length. Okay. But if we saw this for sine, all right, let's go back to that graph for a moment. Make sure we draw those 3 petals in the correct location. All right, that petal is on the bottom of the x-axis. Okay, so 3, but coming through our 3 pi over 2, if you will. So what does that mean? It means that our picture might look something like this. 1 petal, 2 petals, 3 petals, but that this distance is our A. Okay. Now, when we have n is odd, we actually only have n visible petals. We only see a certain number of petals. But as it turns out, even though we only see 3, it turns out that there's actually 6 petals here. In fact, we see like 1, 2, 3, and then the next 3 are right on top of the first 3. So we actually have 6 petals here, and we have 6 petals here. We just can't see them all because half of them are exactly on top of the other half. Okay. All right. So one note we might want to write for ourselves is that when we have cosine, our x-axis is our axis of symmetry. But if we're looking at sine, our y-axis is our axis of symmetry. Okay, so we should really just go back to that idea in the unit circle. Cosine is x, sine is y, and that will help us determine the axis of symmetry. Okay, all right, let's take a look at this equation. R equals 4 sine 2 theta. All right, petal length is given by that first number. So I know the petal length is 4. the number of visible petals is by our n value. All right, so because we have 2, 2 is even, so 4 visible petals. Okay. Axis of symmetry, well, we have sine, so the axis of symmetry is the y-axis. All right, now let's plot a few points and see if we can figure out at least where that first petal is. Because once we know where the first one is, we can sketch everything else after that, okay? So I'm gonna go ahead and plug in 0. Sine of 0 is 0 times 4 is 0, so I start at the origin. Now, I'm going to plot pi over 4, all right? So when I plug pi over 4 into this equation, I get 2 times pi over 4, which is pi over 2. And then sine of pi over 2 is 1, and then 1 times 4 gives me 4. So 0, comma, 4, comma, pi over 4 is the end of one of the petals. All right, so if we sketch these here, we've got 0, 0, and then 1, 2, 3, 4. So I know that one petal goes like this, okay? Now, I can actually sketch the rest of it. I know that there are 4 petals. I know that they are symmetric about here, and they should be evenly spaced. So I should end up with a petal here, and a petal here, and a petal here. All right, and we can see here that this petal length is 4. And so everything matches. We've got our petal length, the number of petals, and our axis of symmetry. Okay. All right. I'm going to leave example 4 for you to try on your own. All right, go through it in the same way. We're predicting first, so make sure that you predict first. But the reason why I'm not going to help us fill this out completely is because we can always check with Desmo, right? So be honest with yourself. Do the prediction, see how you do, and then check your answer with Desmos. Okay, so we'll leave a note here that you should check with Desmos. All right, but a great practice problem for you to try. All right, folks, that's it for this part 2. Come on back in part 3 where we're going to take a look at a third shape.